Can a machine think? Yes, if we give the word thinking an operational meaning. Thinking is not merely producing a fast answer. It unfolds in time. A system must hold a goal, compare alternatives, delay an action, remember what happened, detect error, and change its next step. A single response is an event. Reflective thought is a controlled sequence of events, connected across time. Nature gives us the model. The human prefrontal cortex helps organize goals, attention, inhibition, planning, and error correction over time. MD-OS does not claim to copy the anatomy of the brain. It translates selected executive functions into an artificial control architecture. Persistent context, task scheduling, permissions, interruption, observation, verification, and memory. The important idea is temporal organization. What happened before must influence what the system is allowed to do next. The computer already has an operational control surface, the shell. The shell joins human intention to the operating system. It changes directories, starts programs, connects streams, manipulates files, and exposes results. The UNIX tradition showed that small processes become powerful when explicit interfaces let them work together. But a conventional shell understands commands, not the evolving meaning, evidence, and commitments of an artificial agent. Cortex makes the concrete step of joining these two worlds. The machine's operating system shell and the MD-OS operating file system become one agentic operational surface. In simple terms, the user keeps full shell control, while work can be delegated to the machine just as rapidly in natural language. A valid native command can act directly. A natural language request can enter the complete reasoning and tool loop. The same directory, files, effects, and readback remain visible to both. The operating system supplies processes and devices. MD-OS supplies identity, context, policy, memory, semantic gates, and verification. Cortex binds them into one continuous operation. This changes the role of a knowledge repository. It is no longer only a library that an agent reads. It becomes an operating context the agent can enter. Moving to another repository can rapidly select a different body of knowledge, rules, state, and history. Returning restores the earlier context. Separate repositories remain independent, while verified artifacts, explicit links, and bounded connectors let knowledge travel between them. The human can therefore give the machine the right knowledge for each task, move quickly between domains, and connect them when useful, without mixing everything into one hidden conversation. The shell is therefore more than a convenient interface. It is the point where we can govern the flow before and after the model. We do not see every internal state of a probabilistic neural network. We control its operational boundary. We can preserve the exact request, select context, constrain authority, observe tool actions, capture effects, and inspect the answer before it becomes an action or a durable belief. Input and output become parts of an explicit system rather than disappearing into an opaque exchange. Generated text is not yet an effect in the world. A candidate can become a typed action specification. Semantic, policy, and capability gates decide whether it may reach an executor. The executor produces a receipt. A sensor observes what actually happened. A verifier compares the expected result with the evidence and returns verified, failed, blocked, or uncertain. Only authorized consolidation may turn the result into persistent knowledge. The output of one step becomes trustworthy input for the next only after crossing its declared gate. Now time closes the reflective loop. A first candidate returns as new input to distinct processes. One proposes, another criticizes, another checks evidence, another revises. If criticism exposes a defect, the proposal travels around the loop again. If evidence is missing, the system waits, measures, or reports uncertainty. Every cycle has a budget, a stopping condition, and a record. The machine can talk to itself, but it does so through roles and artifacts that remain inspectable. Reflection becomes real when it can correct behavior. An authorized action changes a file, a program, an application, or a device. Then observation returns from the world. The system compares expected and observed results and chooses to continue, correct, inhibit, or ask for help. Past, present, and possible future are connected in one operating cycle. This is why time matters. Without persistence and feedback, there is only reaction. With them, there can be deliberation and correction. So, can a machine think? In this engineering sense, yes. Cortex is the concrete fusion point between the machine operating system and the MD-OS Artificial Prefrontal Cortex. It gives the human full command of the shell while making it fast to delegate work to the machine, supply the right knowledge, and inspect the result. It turns repositories of knowledge into operating environments and channels input, action, observation, and output through one controllable flow. This creates maximum practical interaction between human and machine, direct when the human knows the command, semantic when the human delegates an objective, and reflective when the system must check and correct itself. This is not proof of consciousness, and the architecture is still evolving. It is the first practical foundation for governed artificial reflection.